Now, we are going to talk about metacentric, submetacentric, and acrocentric chromosome. But before that, I like to remind the short arm we usually call it P, and long arm we call it Q. You can remember P is before the Q, so shorter than the longer. Okay. The end of the chromosome we call telomere, and the center of the chromosome we call it centromere. Centromere, you remember, it's non-coding repetitive region, and telomere also same. Okay, and the exception of satellites, when they are satellite stop, they can have repetitive regions, but that can be coding for rRNA, ribosomal RNA. Okay, in summary, okay, when the centromere is in the middle, and we can't exactly difficult to in finding the P arm and the Q arm, that is a metacentric chromosome, almost equal distance from the centromere, the all both are. Okay, then the submetacentric is the ideal, not ideal, the classical one we explained. The short arm is Pu and the long arm is Q. That is a submetacentric. Then if you go to the acrocentric, here you almost don't have a P arm here. Only you have Q arm only. Okay, and there's a satellite with the satellite store. Okay, then let's move. So we can divide acrocentric chromosomes. What are those? 13, 14, 15, 21, 22, and Y. Then we'll see metacentric chromosomes. Metacentric mean the centromere is in the middle and difficult to identify the P and the Q. So 1, 3 here, 2 entries, so several are there. Okay. Then other one is submetacentric. That's the classical, typical one we explained, the short P, long Q. These are there, but I think we don't have to remember these names unless we are working in a laboratory, right? Whether it's the submetacentric, metacentric. Actually, laboratory person might need to know this because they have to identify in the lab. Okay. Now we are going to talk more details about the acrocentric chromosome 13, 14, 15, 21, 22, and Y. Why I am talking about those? Because you remember, these are the mostly present in that nucleolar organizer region, that is in that when it is formed in the nucleolus. You remember in the previous video, right? Okay. The other thing is this involve many structural abnormalities such as Robertsonian translocation. These acrocentric chromosomes are involved, especially Down syndrome, 14-21 translocation, okay, or 15-21 translocation. There can be several translocation in the 21 leading to Down syndrome. And other special thing is in the human beings, okay, most commonest translocation in the human is 13-14 translocation, that mainly seen in subfertile female. Okay, so between the 13 and the 14 translocation is seen in subfertile female. And among the Down syndrome patient, they can have 14-21, 21 translocation. Those are common among the Down syndrome patient, but all over all human, the most commonest translocation is between 13 and 14 translocation. Okay. There are other classification systems for the chromosome depending on their length and the different parameters depending on the position of the chromosome. Likewise, there are different classification. I'll go through that. So there are from A to G, there are several groups, and 1 to 3 in the A and 4 and 5 in the B. Likewise, there's a different classification. We'll here. A, chromosome 1 to 3, largest and the metacentric. B, 4 to 6, they are medium and submetacentric. C, 6 to 12, medium and submetacentric. D, 13 to 15, medium and acrocentric. E, 16 to 18, medium metacentric and submetacentric, medium short one. F, 19 to 20, and G, 21 to 22. Here, smallest metacentric Y chromosome in the G. So where is X chromosome? Let's see. It's here in the C. 1 to 3 A, 4 to 5 in the B, 6, 12, and X in the C. Okay. Our next topic is polymorphic variants of the chromosome. Thank you.